My name is Dusan and I'm a researcher at the Institute of Physics Belgrade. Along with other colleagues from the C region, we began setting up the NI4OS-Europe node following the EOSC Beyond sandbox documentation. Using these guidelines, we successfully deployed the resource catalog, front office, help desk and AI components. All these components we integrated with the EOSC Beyond sandbox and registered them in the node registry. Practically, this process helped us expand the resource catalog further by adding new resources from the CESDA node, providing our end users with access to a broader range of research tools and products. Also, by connecting the sandbox AI and help desk, we effectively enabled all other nodes to access and request services from our resource catalog using their own institutional credentials. I will illustrate this through my research, which focuses on ultra-cold atomic gases, especially Bose-Einstein condensation. Here at the Institute, I work in the scientific computing laboratory, so much of my work involves creating various simulations of Bose-Einstein condensates. Using the NI4OS-Europe node, which is integrated with the EOSC Beyond sandbox, I can easily keep up with the latest developments in these fields. As an entry point, I use NI4OS-Europe node's front office, which is the front end of the NI4OS-Europe catalog. Both the catalog and the front office are built on the components provided in the sandbox. Here I can browse data and literature repositories as well as services relevant to my research. Recently, I found this paper in one of the repositories listed in the NI4OS-Europe catalog. Besides the results, I discovered that the authors also developed a code for full 3D simulation of Bose-Einstein condensation in an optical trap. It appears that the source code repository is also registered within the front office of the NI4OS-Europe node, which is beneficial because it means that it is integrated with the sandbox AI, allowing me to access it immediately using my institutional credentials. I decided to browse the code a bit to see how challenging it would be to adapt the existing code to my goals. Specifically, here I want to introduce some modulation of the trap, and I'm curious about how the trap's potential is defined within the code. I found that the function that initializes the trap potential is called only once at the beginning of the program. This means that in my case, I will need to call this function at each time step. Therefore, modifying the code to suit my needs should be fairly straightforward. However, to do so, I will need a development environment where I can modify the code and test it. So I'm returning back to the front office where I'm searching for generic resources, particularly HPC resources that I can utilize. Here I found the Paradox 4 cluster, which, according to the access policies also available in the front office, supports users from Serbia. I want to confirm this, so I decided to open a ticket to support team. I can do this directly from the front office since it is integrated with the NI4OS-Europe help desk system, or I can go directly to the help desk. Here, since it is also integrated with the EOSC Beyond sandbox AI, I can log in using my institutional credentials and ask for further clarification. A few days later, I received the Paradox 4 login credentials, and now I'm able to log in and test the code. I found the user guidelines in the NI4OS-Europe catalog as well, and also explanation how to use Visual Studio Code editor at the cluster. Using this, I was able to develop a new version of the code and achieve some interesting results, which are illustrated here. The workflow I illustrated relies on the EOSC sandbox AI, helpdesk catalog and front office components, as well as on services from the exchange layer that are integrated within these components. Our primary objective within the EOSC Beyond is to centralize all resources within a single hub, the NI4OS-Europe front office. This approach streamlines access, links datasets and services, and minimizes redundancy. The illustrated workflow still needs to be expanded to include registration of the produced datasets with one of the repositories already integrated into the NI4OS-Europe or CESDA catalogs, as well as development of services for visualization using available cloud resources. This will be addressed in near future.